Huh. Welcome to the PCD for Eduron 177. I'll be explaining A to E. I couldn't solve in complex. I know the in general approach. The problem है 2 kgs of berries, 2 kgs of sugar, make 3 kg of jam. Now how many berries needed to make n 3 kilogram jars? Every 3 kilogram jar requires 2 kg of berries. So your answer is n into 2. You just say n into 2. Good. I guess this was straightforward. Moving to B. In B, you are given an array B, which is created from basically copying the array A k times. So this 2, 3, 1, 4 just gets repeated. Simply up. Given a number x, it is required to count the number of positions L for which there exists a position r greater than equal to L such that sum of the elements of array B on the segment L to R is at least x. Now, and the constraints are nk 1e5 1e5. So your entire array B is of size 1 raised to 10, which is too much, and x is 118. AI is also 118. Now x. Now let's just take this example. First one. Okay, so this array is copied 3 times, so that is the entire array. Now if you were to do this in a normal array, find all the L such that there exists an R with same thing. You just iterate over every value, and now when you are here, you binary search on the first value such that this entire sum is greater than equal to x, and that you can do by building a prefix sum. Like in general, when these sort of problems are there, you do a prefix sum to get sum in a range in of 1. So prefix sum, if you build, you'll get 9, 10, 15, 18, 22, 24, 25, 30, 33, 37, 39, 40, 45. This is the prefix sum you'll get, and now for every L, you'll just end up doing binary search and get the answer. But now the problem is, this is B, and I can't really make B entirely, because 10 raised to 5 into 10 raised to 5 is 10 raised to 10, which is too much. Like it will give TLE, MLE, everything. So, now how do you do this? So now we need to be a bit smart with how we get the sum in the range. Now binary search we'll still do on 0 to n into k. But now if I want you to tell me what is the sum between L and R without actually constructing the entire B, is what we need to figure out. Okay. And then L also will only bound to n items only. And I'll do that here. So now given A was this. Prefix is 3, 7, 9, 10, 15. Okay. Now if you are at 3, okay, and let's say you are given x is 10. Assume if your R pointer is here, which is in this array, if you are at an L here and the R is somewhere here, Here the difference is what? 22. Pretty evident. Okay. These are the barriers. No, these are the. Here the difference is very evident. It is like the sum is basically 25. But now I don't really know where R lies. R technically lies over here. If you do R mod n, wait, I'll come back. Now technically R, if you see 1, 2, 3, I just mark 0, 1, 2, 3, 4, 5, 6, 7, 8. If L, I'll just write it formally. L equals 0, R equals 8. How do I get the sum? Right. Now technically if you do R mod 5, you get 3. So your R is technically present over here. Now to get this R, you will need to traverse this part and then you will need to get this entire R. Like, let's take a bit different R. Let's say the R is over here. Now the sum between N and R, this entire thing is constant. It's just the entire sum, right? Which is basically prefix of N. This entire thing you can get by doing prefix of N minus prefix of L minus 1. This part. And now this part you can get by doing prefix of R. So now if you see, if you want the sum, okay, this entire part and this entire part is going to remain the same. This part is not prefix of N, it is prefix of N into R by N minus. What is this? Now R by N basically gives me which block I am in, which block. So when you are an 8, when you are at an 8 by 5 is 1. Now I don't consider 0th block, I don't consider rth block, so everything in the middle is R by N minus 1. So if you want the sum between any L and R, you do this, and R is also R mod N. So this is sum. Does this make sense? Hello.
Yes, yes.
Yeah. So now once you get this, you can do binary search. So now you can do binary search for every L from 0 to N. But how do I get for other N's? Right? Here there are only 0 to N. I need for other N's also, right? So now comes the main like a very good idea. I'll just copy this here. This is the barrier. Now let's say this gets 10 at this index, right? Now for starting from here is same as starting from here, same as starting from here, except some part of the suffix goes away, right? So, like, since it is internally only, this entire sum is also going to be greater than equal to 10. This entire sum is also going to be the same. Like, these four sums are one and the same thing. Okay. So for this also L counts as an answer. Now, for example, if my L and R is something like this, then what do I do? If I shift this by n, what will happen is I'll get this, which is also valid. But shifting this, I can't do because there are no elements over here, right? So how do I basically know how many times this is gonna happen? Basically, if you are at an R, basically you found the first index where it is greater than or equal to x. Answer plus equals k minus r by n plus 1. Basically, like this r you can shift only at most till k, right? Till k. This r, if you do add n more, and then that at most will go to k. So, or else you can do n into k minus r by n. Same thing, but yeah. Does this make sense? Basically, how many times can I shift r and this r satisfies? If you have that r, the corresponding L always exists. Make sense? Hello.
Yes.
So if you come to the code, B So now first I make the prefix array. I have this getSum function. Basically, I get the index of the block, which is r by n. If it's in the same block, then I just get the prefix. Simple as that. If it's not in the same block, firstly I get this part. This part, which is prefix of n minus prefix of L minus 1. I'm doing n minus 1 because I've done 0 base indexing, but same thing. And then what is this? This is basically the middle part. Prefix n minus 1 into index minus 1. Index is r by n, as I did. And the other part is r mod n, which is r mod. And then return sum. That is it. That is my getSum function. Now for every I from 0 to n, I do binary search. I get the sum. If it is less than or equal to x, this is just else. And then, yeah. Now, if this L, basically the first value, this R, basically, R or N actually they do the same thing, R or N. It is greater than n into k plus 1, basically there is no such sum possible, then you continue, or else you get the index of this block, which is L by n, and then you do k minus n. Oh wait, plus 1 doesn't exist. So yeah, you do k minus n and then you just add it to the answer. Does this make sense?
Yes.
Yeah. So moving to C. C, you're given a permutation. At every query, you replace P of di with 0, and then each element is replaced with 0 exactly once. Now, to solve, now you need to figure out, after doing that, what is the minimum number of operations to fix the array. Fix the array is basically make it into a permutation of n integers, And you can do that by basically choosing an integer I and replace the ith element with I. Now whenever I see this type of question, I make some array, I make different permutations 4, 2, 3, 1. Okay. Now if I make this 0, what will I need to do? Okay. So if this is 0, 1, 2, 3, I'll obviously need to fix this. So I'll have 1, 1, 2, 3. Now I have an extra 1. So I change this to 1, 2, 2, 3. I have an extra 2, so I change this to 1, 2, 3, 3. And now extra 3, I can change this to 1, 2, 3, 4. You can think in the same terms of abhi I did 1, 2, 3, 1, 1, 2, 3. I'm missing a 4, so I do 1, 1, 2, 4. I'm missing a 3, so I do 1, 1, 3, 4. And I'm missing a 2, so I do 1, 2, 3, 4. Same thing, at the end of the day, the operations is 4. Now let's see for this one. Wait. For this array, if I just change it to 0, 2, 3, 1, I'll make this 1, 2, 3, 1 and then 1, 2, 3, 4, and this is it. If you see, my answer over here is 2. How are these two different is what I look at. Now let's see which. Now here, whenever there is permutation type of questions, it's usually some kind of cycle stuff, but in not thinking of cycle, let's just think of at an index, if I am not, like basically if p of I not equal to I, then I go to that index. Basically 4 depends on 3 ka value, 3 3 depends on 2 ka value. Basically if you do here 4, 1, 2, 3, 4 is at fourth index has 3, third index has 2, second index has 1, and first index has 4. So if you see, this is some sort of a cycle, and over here the cycle is this and this. Same thing if it was 4, 3, 2, 1. If I replace this with 0, I'll get 0, 3, 2, 1, 1, 3, 2, 1, and 1, 3, 2, 4. So these two are part of a cycle and these two are a part of a cycle. This element is a part of its own cycle, this element is part of its own cycle. Okay. If you see this, now whenever I make a part of a cycle 0, I'll have to resolve every single one. Basically, if you see here, I made one element 0, I'll have to resolve every one. I'll have to do operation on every element of the cycle. So that is why our answer is 4. Over here, it's a cycle of 2 size, so answer is 2. Cycle of 2 size, answer is 2. Even if I make 4, 3, 2, 1 and I make this 0, I'll end up with 2 operations only, because this is a part of a cycle. Now let's see what happens when there are many queries. Okay. Now 0, 3, 2, 1 hua. From 0, 3, 2, 1, let's say I make this 0. So now what will happen? I'll have 1, 3, 2, 0 and 1, 3, 2, 4. What is happening over here is the answer doesn't change if 2 elements with 0 are part of the same cycle. This increases my answer. The first 0 increases my answer. The second 0 in the cycle doesn't increase my answer. My answer remains the same. But if I have 0, 0 to 1, then I'll have to do 1, 0, 2, 1, 1, 2, 2, 1, 1, 2, 3, 1, and 1, 2, 3, 4. over here my answer becomes 4 because I am doing something else on a new cycle. So my answer increased by 2. So now that is it. So now what we do is we figure out which element, which index belongs to which cycle. We then have a visited of cycles, that if a part of a cycle is 0, then I just don't consider any other zeros in the future. And then answer plus equals size of a particular cycle of the index which becomes 0. That is it. That is what you do. If you come to the code, see. So now cycle, technically, like, it may look a bit daunting because cycle comes from a graph topic which people might be unaware of or be very scared of, but this kind of cycle is very easy to do. The code is basically, for every element which I have not considered, it is a part of a new cycle. So it's part of a new cycle. I have a do while loop. Now cycle dot pushback j, because j basically I is j, cycle dot pushback j, and I visit that index, and then j becomes a of j. Basically, the way we figured out it's a part of a cycle in our escalator over here is, when I'm at a 1 and I see 4, I go to 4. When I am at a 4, I see 1, I go to 1. So that is it. When I'm at a 1 and I see something else, I go to that index and I go till I return back, and that is j not equal to I. Now at the end of the day, I just push back into my entire cycles. You can do it more efficiently, but this is just how I did it. Doesn't really matter. Now I just have for each index which cycle it belongs to and what is the size of the array. Left is just size. Now for every cycle, for every element in the cycle, I just give that index of cycle to the element and then I increase my size. Now for every d, this is just considered or visited of cycles once again. Now if I have not considered this cycle, then I increase the answer by the size of the cycle and I consider that cycle, and at the end of the day I print answer. That's it. Does that make sense overall?
Yes.
Cool. Now moving on to D.
तो वैसे थोड़ा सा फास्टर कोड वुड बी इफ यू हैव डीएसयू का टेम्पलेट, तो डीएसयू से बहुत फास्ट हो जाता है.
Yes, DSU it is, but ये कर लिया मैंने. If you guys want to look up DSU CPL go, and this will give you DSU, but if you're not familiar with graphs or something, this might seem bit advanced topic, which it is. This is very simple. You're just manipulating arrays. DSU just makes everything easier. You can get the size of the cycle. You can get everything very fast. So yeah, DSU is just superior. Now D is a question where you need to construct a string S such that for every pair ij where both the characters are equal, the difference in indices is even. But constructing any string is very easy. So what they want you to do is count the number of distinct string S which have the particular characters given, basically required number of occurrence of each character from 1 to 26. Now this is the frequency, basically frequency array given. I want to construct a string with this frequency array, and I want to count how many such strings are possible. Whenever it's how many or number of something, number of distinct strings, whatever, it is some kind of dynamic programming, DP. And over here, what kind of DP can you make? Now, very simple thing is, you can have 5e5 as your number into 26. 5e5 into 26, you'll have 3, 5, 7. 1e7 ka array. Okay. If you make n into, like, basically the sum of ci doesn't exceed 5e5, so your entire DP state you can make is whenever, like, DP state at max I can use is 26 into n. Like, I can have some other things also, but at most I can do 26 into n. So now how do I go about this DP? Okay. So now if now some other observations, very basic ones. Like, for example, if this is the array A, B, I have these empty spaces and I want to assign 3 numbers, okay? I want to have a frequency of 3. Basically, I want 3 A's to put it. Since the difference has to be mod to 0, either they'll go in all odd places or all even indices. Does that make sense? Basically, either they'll be part of this or they'll be part of this. Make sense? Yes, no?
Yes.
Yeah. So now, if let's say I want to do it for even, how many even indices are there? Let's say I'll start from 0. The number of even indices are 4, and I want to choose any 3 of them, right? So 4C3, if you recall from maths, 4C3 is 4 choose 3. Out of the 4 indexes, I want to choose any 3 indices and put it there. Put A there, right? So how many ways to do this is 4C3. Correct?
Yes.
Now let's say I have done this. So what will happen to my array? Let's say I choose A, and this. Or I had what option? I do odd indices, right? Same thing for, to or I have 4C3, correct? This is for even and this is for odd. Now let's say I have chosen an even. Now if I have a frequency again of 3, how many even indices are left? There's only 1 even index left. Well, there are 4 odd indices left. So I have, here I will multiply 4C3 again. Does that make sense? If, for example, I have index comma number of odd indices left comma number of even indices left, then, like, basically let's just represent it by I, odd and even. Then DP of I, odd and even, if you just look at this format, will be what? Odd, choose of odd comma A of I into DP of I plus 1, odd minus A of I, and even plus Either you'll do this or you'll choose even comma a of I into dp of I plus 1 odd minus odd and even minus a of I. Correct? If I have these three states, then do these transitions make sense? Yes, no. Basically, I choose the
Yes.
indices and then I go on to the next one with lesser indices in the future one. Correct? But now the problem is, how many odds can be, how many evens can be there? N by 2 and n by 2. Correct? So my how much memory do I need? I need 26 into 2.5 V5 into 2.5 V5. Correct? This is too much. Yes, this is greater than 1E8. Very much greater. So now you need to kind of optimize this. Okay. Now, how do you optimize this? It's a very beautiful thing. And it's a very common technique used in some kind of DP problems where these two numbers are related. For example, if you want to calculate some kind of area, okay, and you have state of area, length and breadth, then don't you see breadth is dependent on length and area? Correct? I can derive breadth from these two things. Correct?
Yes, sir.
Huh. Since I can derive breadth from these two things, I can basically remove this state. And I have optimized this DP basically. And then when I want to do something with breadth is just area by length. Simple. Similar funda over here. Odd and even are basically related. But how are they related? Now, if I have I and even, let's say, what do I know? There are even, like let's say, even number of even indices. Let's just call it E number of even indices. One more thing I know which is very important is, before I have chosen everything, right? Before I have chosen everything. So total number of remaining indices is equal to n minus prefix of I minus 1. Does that make sense?
Yes, yes.
Huh. Now if I have total number of remaining indices, I know there are E number of even indices. Can I get odd indices? You can just do total remaining minus E. Does that make sense?
Yes, sir.
Exactly. So now, with only I and even, you can get odd also. And then the same thing applies. Here you just remove this odd constant. That's it. Now the entire DP is same. Transitions, everything remains the same. You just remove this state. That's it. Does that make sense? And then that's it. You just code this up. Now, how do you code this up? I'll show you my code. This is my mod template, and now once again the choose thing, very important. This choose NCR equals n factorial upon n minus r factorial into r factorial, right? Now if you want to calculate very efficiently, you can store these values. And this is also in bracket. You can store these values in factorial and everything under mod. So what we do is, you store factorial and inverse factorial as vectors, and then whenever you do call choose n c k, you just multiply factorial of n multiplied by inverse factorial of n minus k multiplied by inverse factorial of k. Do look up modular arithmetic, modular inverse, modular multiplication, modular division. This is very important, and this template basically helps me do the modular everything with just normal multiplication. So yeah. Now what I do, I take the input, I store total number of n, which is the size of the string which I need to make, which is summation of I. Now I also make the prefix. Now I have the dp I comma even. You can do this. No wait, this derivation was kind of wrong. Idhar. Huh. Total number of remaining indices, no? This is total number of
Used indices.
used indices. So that is what I do. First I get total number of odd indices is n by 2, total number of even indices is n plus 1 by 2. Now used is just total even minus even. And the used even, basically I can just call this used even, and then left or this is used odd. Used odd is prefix of I minus used even, correct? Because total number of used is prefix of I. If you subtract even, you will get used odd, and number of odds left is n by 2 minus used odd. Make sense? Yes, no? Now I just do this. I think you can just return 1, but I was just paranoid. When I is 26, you reach the end, you return 1. And when you've already visited the state, I initialize dp with minus 1, because minus 1 is never possible. Whenever, and when ci is 0, I go to self. Actually, this doesn't really matter. This doesn't really affect everything. So now the answer is 0 if even is greater than c of I. Basically, if I have enough evens, then I do choose even ci, and then I subtract ci from even. I do I plus 1. Or else I choose odd and I don't subtract from even. That's it. And then I store the answer, and then I just print the answer. Make sense? Yes, no? So now coming to E. Unfortunately, I went down a very wrong path in this question and couldn't solve, but the observations were there. Okay, I could have solved it. E हो जा lower. So now zebra numbers are just 1, 5, 21, so on. Basically 1, 101, 10101, then 1010101, and so on. Now we define zebra value of a positive integer e as the minimum integer p such that E can be expressed as the sum of p zebra-like numbers. Given LRK, we need to find number of integers x between L and R such that the zebra value of x is k. Whenever it's something like this, the first thing you need to do is you instead of counting L less than equal to x less than equal to R, you count x less than equal to R and you subtract it with x less than equal to n minus 1. This comes from prefix sum only, but yeah. So what is this? This you can just write a function which gives all x such that x less than n less than equal to n and zebra of x equals k. So now we need to figure this function out only. Okay. One thing to notice, k, you are given 118, but what are the possible values of k? Let's just see, okay. Not in possible values of k, let's just see the numbers, okay. 1, 5, 21, 21 plus 4 in 4 is to 3, 85, and so on. Right? 1, 5, 21, 85 and so on. Whenever you have something like summation of this entire thing is less than this, basically. What do this? This kind of binary, like, whenever I need to find the zebra value of a number, okay, zebra value of a number, zebra of x, you can just up lower bound among zebra and it becomes 1 plus zebra of zebra numbers 1 plus zebra of x minus LB. Okay, this is the whenever you take a number x like zebra number, you always take the largest one because the summation of this is less than 85. Okay, whenever it's something like this, you can just do greedy choosing, and it's kind of like a coin change problem, greedy coin change. Whenever, let's say I have 8, so for example I have 100, I'll take 85, so 100 minus 85 is 15, then I go to 10, then I go to 5, and then I go to 0. So basically it took me 1, 2, 3, 4. So zebra of 100 equals 4. This is 100% correct, and this is a property whenever the summation of previous numbers is less than my current value. You can just greedily choose the numbers. So now zebra of x is just lower bound among the zebra numbers, and then your value just becomes 1 plus zebra of x comma LB. Okay, pretty straightforward. Now, if you're doing something like this, what is the maximum a number can be? Okay, 1, 2, 1, 5, 21, 85 and so on. This kinda you can do look at it as a base 5 representation. At max you can have 4 ones, 4 fives, 4 85s and so on. Actually not even that. I thought of as a binary thing and that's why I went down a wrong path. But having 421 and 1 1 is same as having 185. So at max a number can have 4 but not necessarily ki everything will be 4. If you have everything will be 4 then you're ending up having a lesser p-value, the greater p-value than what it actually can have. So yeah, at max a number can have 4 because other than that otherwise you just do 1 over here, but you can have a series of 4s. That's the main thing. So assume all are 4s. So what is the max k it can be? There are the zero numbers till 118 or 30, and let's say assume there's 4s. All 4 is not possible only, but assume it's all 4s.
हेलो
Hello.
मेरा नेट गया कि जेनल का नेट गया? हेलो, कैन यू
तेरा
हियर मी?
नेट गया, मेरा नेट चल रहा है. हेलो. I can hear you, man. Hello. So worst case 30 into 4. So it is 120. Like 120 is also a huge upper bound. So not huge, but it's an upper bound. So 120 at most k can be. So whenever k is greater than 120, you just return 0. Your answer is 0. There can't be any number with k greater than 120. That is for sure. So now since k is bounded by 120, for a number r n given k, you can have a dp of n comma k is equal to, either you'll end up with, you'll use a lower bound which is n minus lower bound comma k minus 1, or you'll skip this lower bound and you'll end up with a number lb minus 1 and k minus 1. This is the very important transition state. Now since these transitions are going very drastically and you're going lb minus 1, lb minus 1, you can store all of this in a map. Instead of having a dp table, you can have map of int comma long comma long, and then of dp, and kinda basically have this global map, and then it'll satisfy, like you'll be fitting into the constraints, and yeah, that is it. This is the main thing. Why lb minus 1? Because if I'm not considering lb, I should consider everything else, not the lb. So you do lb minus 1. That is the main thing. That's it. Makes sense? And pretty just simple code. You can just check out Dominator's code. He uses maps only. So he has a map of pair int. His int is long, and then the base case is if k is 0 then return 1, but if x is 0, k is not, then return 0. If you found a pair, then you return that, or else you just, this is just lower bound. You can even iterate because at most is 30, and then his state is x minus y or y minus y. That's the same states, same answer. and then you can get it for r comma k and l minus 1 comma k. That's it. So yeah, that is PCD for A to E. See you day after tomorrow. Codeforces around day